Hi class, we are going to write a function to insert nodes at the head of a linked list. What did we do earlier in the last video? We created one node to our linked list and have the value or the member variables inside the node set up already with data equals to 10 and then the next pointer pointing to null pointer because that's the last node. How did we get here? If we look at the code again, we will see that what we need to do to create to add a node to a linked list is to create a new node, and then we set up the data, we set up the next pointer, and then we are done. So we just need to take care of the case that the first one has to have null pointer as the next pointer. And then you can see that once this one is set up with the next pointer pointing to null pointer, the subsequent one that we will insert from the head, right? So we are inserting 10, and then we are inserting 9, and then we are inserting 8. How we did it is that the next pointer will point to the node that was created before, or the list that was created before. To define this function, we of course write about the purpose. The precondition is that head is pointing to an existing linked list, or actually I would say that or if not, then is pointed to a null pointer. So I will change it actually. So want to mention one thing though. So you can see that we are passing the pointer as a reference, meaning that we can change the value of the head pointer that's being passed into this function. So think about why. Very simple. The case where head is not pointing to anything anything yet, right? And then it's pointing to a null pointer, and so if we not passing anything back, no matter what we created here, head would be still pointing to the null pointer when we finish this function. And that's why it's very important for us to pass this variable head by reference so that head can be changed. And then we pass the data that we want to insert into the new node, which we call it new data. Let's see what's the mechanism. So right now head is, I think right now we want to look at the case where we already have something in the linked list, but it doesn't have to. We can check the boundary case later on and see how to change the code. So let's think about a more generic situation where head already have a record and we want to insert something in it, another node in it. First of all, we want to create another pointer called insert, and then create a new node that we are going to insert into it at the head to the linked list. And then we probably would put some data in here, say 9. That's what we want to have the data to be. And then we want next to be pointing to this node, right? So we want it to be pointing to the same node where head is pointing to. And then we want to change head to okay, let me put it here. And then we want to change head to be pointing where insert is pointing to. So then we can delete this link and then allow insert to do whatever. So that's what we want to accomplish. So let's write down our plan. Honestly, this is more complicated now, and so we need a plan. So what we did was we created a new node pointer called insert. We created a new node so that for insert, and then we set this new node's data to new data. We set the pointer to the pointer of where insert is pointing to, that node. The next point to what head used to point to. And so it means that if head is pointing to null pointer, next will be set to null pointer. So we already checked now that the boundary case actually works for an empty list. Then we will set head to equals to insert, right? And then we will set insert to null pointer just so it's not dingling, basically. Like I said, we already checked the case that if head was originally pointed to null pointer, this will still work. At the end, head will still be the head of the revised linked list. So head actually, the head will exactly be where it is, but the value has changed to not point to a null pointer anymore. So the tips about linked lists and pointers, as you can see, why in these few videos I've been using Visual A's, I've been creating drawings for you, because it's so much easier to understand and not basically make, well, I will put it this way. For me, it works really well. I think when I was learning this, a lot of my classmates was having troubles, and I can tell you that maybe that's why I'm teaching you right now. And I hope you can ace this, because you can see that a lot of people are having trouble with this. And if you're good at this, you should pat yourself on your back that you understand this really well, because it's not a simple concept for a lot of people. I would say that using drawings and visual aids to understand the concepts and how the pointers pointing to each other, and which is a pointer, which is a record, which is a variable, I think once you draw it or try to understand it visually, you will have a much better hang of this concept. I would tell you that to differentiate yourself as a good C++ programmer, being able to use pointers efficiently will help you in your work, and also probably get more respect from your colleagues. I will tell you that. So the demo, let's try to implement this in I see. So you can see that we have the same struct nodes. We have the same node pointer defined. We have the decoration here, and then we are going to implement it. So what we are going to do is the main function, we would have head point to null pointer. This actually is a very important step. If you don't do it, no one knows when the linked list is going to end, or you don't know where it's supposed to end. And we would do, our task is to insert a 10, a 9, and 8 inside the linked list, and then we will print it out using a very simple function. We won't delete head, because as you can see, we would actually do the new 3 times here, right? So delete head is really not enough, so we would deal with this in the next video. Right now, let's implement the head insert. First 2 steps, we are going to create a null pointer that is called insert, and then we are going to create a new node. You see why the plan is important. It can help you to write the code and also double check later on if there's a bug or anything. It's so much easier. And this actually is this. So, and then set the new node's data to equal to new data. So insert is the pointer. Inserts pointing to data, and we want to set it to new data. It's almost exactly like when we were creating the first node, basically. We want the node's pointer next to equal to where head is pointing to. So it's insert next equals to head. So if head is pointing to null pointer, then insert next will equals to null pointer at this point, which is the case for when we call head insert head 10. This step has to come before the next step, so we will set head to something else. Equals to insert. It's very important to know because if you lost where head is, you basically lost the whole linked list. Then we will set insert equals to null pointer, just so it's not dingling. I mean, it's just for, I think it's a good habit because you don't know if later on you change your code and did something. So always not have a pointer dingling is the best idea. So let me save it, and then we will compile it. So it prints out now the linked list has 8, 9, and 10. Because we insert the 10 first, and then we are inserting 9 at where head is, and so it's inserting 10 first and then move 9 to go before 10 and then have 8 before 9. Include the code here just so you can double check. To recap, we learned how to write a function to insert a new node into the head of a linked list. And important thing, so I want to repeat, use Visual 8. Always try to draw them so that you know what you are trying to do with the pointers, with the data, with the pointer next, the head, so on and so forth. I will see you in the next video. We are going to clean up after ourselves. See you soon.